Okay, so we're trying to solve for a here, and currently we've got a square root with a plus 54, and then we have equals a minus 2. And you can kind of play around with it and try to guess, but that would be pretty challenging. So one of our strategies is to kind of eliminate the square root. So I'm going to start by doing that. So the opposite of square root would be the square. So I'm going to have to, but if I square one side, I got to square the other side. So when I do that, the left side will become a plus 54. Now on the right side, I'm going to have a minus 2 squared. And so when I square that, you have to be careful. Sometimes students just try to square the values, but really it's going to be a minus 2 times a minus 2. And we have to go ahead and FOIL this. And so I have to multiply the first, the outer, the inner, and the last two terms. And so that's going to end up with a squared minus 2a, then minus 2a a second time, and then a plus 4. So I'm going to take this and I'm going to replace the a minus 2 squared with that since I did the math over here. At the same time, I'll go ahead and combine those like terms in the middle because I have that minus 2a twice, and that will combine together to be a minus 4a when I rewrite it. So let's see, what do we have now? A plus 54 equals a squared minus 4a, and then a plus 4. Okay, so then what we'll do here is and actually what I have now is a quadratic equation. And what that means is that I have a variable raised to the power of 2, and I don't have any powers higher than 2, right? I don't have powers of 3 or 4 or anything like that. Whenever that happens, you're dealing with a quadratic equation. So you could have something squared, and then you could just have the variable on its own, and then you could have a constant. And so that's known as a trinomial right here. That's what I have. But in order to solve this, typically we like to set it equal to 0 and then manipulate it from there. So that's what I'm going to do. I'm going to go ahead and subtract by a on both sides because I do have a common uh, variable on both sides of a. And then also, I might as well take care of this now too. I'm going to go ahead and subtract 54 from both sides. So I'm going to subtract 54 from both sides. And so what I've done is I've zeroed out the left side. So now I've got 0 equals a squared, and then minus 4a minus another a. That will give me a total of minus 5a. And then 4, and then minus 54 is negative 50. So now I have this trinomial. And so earlier up here, remember I foiled, right? I foiled this out. I'm actually going to do the reverse now, which is called factoring. And whenever you have a trinomial, and in this case the leading coefficient is a 1, that kind of factoring is a little bit easier than if it were something other than a 1. It gets a little challenging. But whenever it's a 1, really what you're trying to do is break this up into two factors. And we know to get that a squared, it's going to be a and a, because a times a is a squared. And then the outer and the inner is where we add up to that minus 5a. And then the last two terms multiply together to give me negative 50. So a lot of times people will call this the A&M method. So we're looking for two values that can add to give me the negative 5a. But then when I multiply those two numbers together, I get the negative 50 right here. And so that's going to be a minus 10 and a plus 5. And the order I put them doesn't matter. I could have put the plus 5 here and the minus 10 back here. But if you were to FOIL this, it's equivalent to what I have here. It's the same thing. I've just manipulated it into a different format. And so now what I can do is these two things are getting multiplied together. So if either one of them equals 0, it'll make the equation equal 0. And that's what I'm being asked to do. You know, what will make this equal 0 in this case. And like I said, we've kind of come a far way. I've manipulated it into this format. And so right here, this one right here would be a 10. If I were to let a equal 10, 10 minus 10 is 0. This would become a 15, but it wouldn't really matter because 0 times 15 would be 0. And then this other case here would be negative 5. If I were to plug in negative 5, once again, it would make the equation equal 0. Now, we have to be a little careful here, though, because we did kind of manipulate this equation. And whenever you do that, sometimes there's unintended consequences. So what we have to do is we have to check it. We need to check this. And so we need to check when, oops, I always like to use X. But anyways, A, we're going to check when A equals 10, or maybe A equals negative 5 and it works. Or maybe they both work, or maybe they both don't work. Typically, one is going to work and one doesn't work, but there are cases when they can both work or they both don't work. So let's go ahead and try the first one. So let's see, if I plug in 10 for A, I'd get the square root of 10 plus 54 is equal to 10 minus 2. So that's the original equation before we had squared it. So I'm going to go ahead and erase that. You got to plug it into the original when we're checking. So then this is going to become the square root of 64 equals 8. And once you know it's true or false, you can stop. So right here, I can tell that that is true. So I know A equals 10 is definitely going to work. So we definitely know that one's going to work. Let's see what happens when I plug in -5. So let's see, I'm going to get the square root of -5 plus 54. Is that equal to -5 minus 2? Well, let's see. I'm going to get the square root of 49 equals -7. That is false, okay, because the square root of 49 equals +7, not -7. So -5 is not going to work. So just cross through it. You do not want to include that as part of your solution. And so there you go. If you need any other help with any other ones, just let me know.